We're going to talk about the algebra of functions. Specifically, we're going to look at adding functions together. So if you had a function like f of x equals x squared and another function like g of x equals x plus 3, and you wanted to look at adding those together, we could do f plus g of x means the same thing as f of x plus g of x. And in this case, it would have a formula like so. If you wanted to find values for these, like f of 2, g of 2, f plus g of 2, there's a couple different ways to do that. So you could plug into each formula. 2 squared is 4, 2 plus 3 is 5, 2 plugged into here, you get 4 plus 2 plus 3 is 9, which note is just the 4 plus 5. Right? So these things are just, really you can just add each point together, which means if you look at a graph of these, really you're just adding the two graphs together, and graphically it ends up making a lot of sense what the graph looks like. So at every single point you're just adding the terms, the points on the graph together to get new coordinates of a new graph. Again, we'll look more at that in a moment. Okay, so the other things that we can do are subtraction, multiplication, and division. Those are the things we're going to do in this video. So the next one that we're going to look at, subtraction is just exactly the same as addition, so we're not going to look at one of those, but let's look at a multiplication example. F times g of x means the same thing as f of x times g of x. If you did f of x is 2x, g of x is x squared, then f times g of x would be 2x cubed. Pretty straightforward. Again, you could plug in and find the values. You could plug into here and here and multiply to get a value, or you could plug into the new formula. You get the same value either way. F divided by g of x means f of x over g of x. So in this case, it would be 2x over x squared. Now let's talk about domains. This is where this gets a little tricky. For f plus g, f minus g, and f times g, the domain is the intersection of the domains of f and g. So as an example, if f of x is square root of x, that has domain 0 to infinity with a bracket on 0. I messed that up earlier. G of x is x squared. That has a domain of minus infinity to infinity. And f plus g has the intersection of those domains. So that means what they have in common. So what f and g have in common is the 0 to infinity part. So that's the part that makes sense to do with this sum. That same rule works for adding, subtracting, and multiplying. Division is a little more restrictive. If you want to look at domains of a division problem, you not only have to look at what the domains have in common, so you do the same thing we did last time. The domain of f here is 0 to infinity, and then we need to remove anything that would make the denominator of our new function 0, which means we need to remove anything that would make g of x 0. Well, 0 would make this 0, so we need to remove 0 from this domain. Well, if you remove 0 from 0 with a bracket to infinity, you end up with 0 with a parentheses to infinity.